I'm completely invisible right now. The camera can't see me. Even the thermal camera can't see me. But something out there already knows exactly where I am.
Today I'm playing the most unfair game of hide and seek ever recorded. Except I'm not the one seeking. It is. If you have been here before, you already know the story. And the first You Can't Hide video, I showed how this tiny mmWave radar could detect people from kilometers away using LoRa. Then in part 2, we tracked 3 people simultaneously in real time on both the onboard radar display and on a custom Python application. I also showed how this technology can secure any detection zone by detecting people and instantly alerting you whenever someone enters the monitored area. So here's what changed since part 2. I received a lot of interesting comments. One suggestion really caught my attention. Someone asked, why are we monitoring everything on this tiny OLED display? Why not make it completely wireless and display the same radar interface on a smartphone? I liked that idea, so I decided to build my own smartphone application using Android Studio. Instead of looking at a small display, I can now monitor everything directly on my smartphone or Bluetooth. Let me show you how it works. If you plan to use this radar outdoors or in different locations, I highly recommend mounting the entire setup on a small smartphone or camera tripod. It makes the system portable, easy to carry, and you can place it anywhere in seconds. Then using the Android application, you can monitor the entire detection area from a safe distance without needing to stay close to the radar itself. At the top, you can see all the live target information including distance, angle, coordinates, and speed. The radar display below updates instantly as I move, so I can monitor everything directly from my phone instead of a tiny OLED display. If you would like to build it yourself, the complete Android Studio project and ESP32 code are available on my Patreon. But the new Android application wasn't the only suggestion I received. After my previous videos, many of you also suggested new challenges, so I decided to include as many of them as possible in this episode. One comment really stood out. This viewer suggested a real hide and seek challenge and asked if the radar could detect someone hiding inside thick bushes. I liked the idea so much that I replied to the comment and promised I would test it in the next episode. Well, today is that day. But that wasn't the only challenge. Several of you also wanted to know if the radar had to remain stationary or if it could still detect people while the sensor itself was moving. Some of you even suggested mounting it on a moving vehicle. So we are going to test that as well. And there is one more thing. Today's video also includes a test that I have never performed before with any mmWave radar. Honestly, I have no idea how it's going to perform. We will save that test for later. Here's how this works. In every round, I will hide in a different location and each challenge will be more difficult than the last. At the same time, we will compare 3 different technologies: a regular camera, a thermal camera, and the Rd-03D mmWave radar running on my new Android app. Every test will be performed under the same conditions, so by the end of this video, we will know exactly where each technology performs well, where it struggles, and which one is best at detecting a hidden person. Let the challenge begin. Let's start indoors where thermal cameras are supposed to perform their best. There is no sunlight, no reflections, and a much more controlled environment. So for our first test, I'm hiding under this bed. The camera loses immediately. The thermal camera, nothing. No heat signature, no indication that anyone is hiding under the bed. But look at the mmWave radar, it detects me almost instantly. Wood, fabric, and even the mattress don't stop the radar from finding me. That's one test completed and one win for the radar. If someone wanted to hide indoors, a table would be a much more natural hiding place than a bed. So let's recreate that situation and see which technology can actually find me. I'm completely hidden under the table now. From where the camera is placed, I should be completely out of sight. Once again, the regular camera has no chance. There is no visible sign that anyone is hiding there. The thermal camera isn't doing any better. There is no clear heat signature that reveals my position. Now, look at the mmWave radar. It immediately detects my position and keeps tracking me in real time. Even with the wooden table between us, the radar has no problem finding me. That's two indoor hiding spots completed, and once again, the mmWave radar has done exactly what it was designed to do. Many people wonder if an mmWave radar can also see through a wall. Let's find out. I'm completely behind the wall now. The regular and thermal camera obviously can't see me, so let's check what the radar does. This time the radar can't detect me, and that's exactly what we would expect. Unlike wood or fabric, a solid brick or concrete wall absorbs and blocks most of the mmWave signal, making reliable detection very difficult. That's actually good to know. Every technology has its strengths and its limitations, and for this radar, solid walls are one of them. But don't worry, we are not finished yet. Now, let's try something much more common. If someone wanted to hide inside a room, hiding behind a sofa would probably be one of the first places they would choose. Let's see how well our three technologies perform this time. I'm completely hidden behind the sofa now. The regular camera can't see me at all. The thermal camera isn't able to detect me either. Now let's check the Rd-03D mmWave radar. Once again, it detects my position almost immediately and keeps tracking me in real time, even through the sofa. We have now tested three different indoor hiding places, and the mmWave radar has detected me every single time. But all of these tests had one thing in common: there was still enough light for a normal camera to work. So let's remove light from the equation completely. For the next test, I'm turning off every light in the room. This will be the first direct comparison between a regular camera, a thermal camera, and the mmWave radar in complete darkness. The regular camera is almost completely useless in total darkness. The thermal camera has no problem detected me. Unlike a regular camera, it doesn't need visible light. It detects the heat coming from my body. Now let's check the RD-03D mmWave radar. Just like in the previous tests, it immediately detects my position and keeps tracking me in real time. Unlike a regular camera, the radar doesn't depend on light at all. So, darkness makes no difference to the mmWave radar, but now it's time to leave the room and see how all three technologies perform outdoors. Here in my yard, I have a tree with a thick trunk that's large enough for me to hide behind. From the camera's point of view, you shouldn't be able to see me at all. The thermal camera can't detect me either. The tree trunk is completely blocking my heat signature. Now let's look at the RD-03D mmWave radar. Once again, it detects my position almost instantly and continues tracking me in real time, even with the thick tree trunk between us. So, a thick tree trunk isn't enough to stop the mmWave radar, but the next challenge comes directly from one of your comments. I'm going to hide inside thick bushes and see if the radar can still find me. From the outside, it should be almost impossible to tell that I'm even here. I'm completely inside the bushes now. From where the camera is placed, you shouldn't be able to see me at all. The leaves and branches completely hide me from view. The thermal camera isn't able to clearly detect me. One reason is that I'm recording this during the summer in the month of July. After being exposed to sunlight for hours, the bushes and surrounding vegetation become quite warm, reducing temperature difference between me and my surroundings. If this test were repeated at night or during the winter when the environment is much cooler, the thermal camera would have a much better chance of detecting me. Now let's look at the mmWave radar. It immediately detects my position and keeps tracking me in real time. Unlike a camera or a thermal sensor, the radar isn't looking for light or heat. It uses radio waves, and the leaves and small branches don't stop the signal from reaching me. So far, we have tested wood, hardboard, wall, fabric, leaves, and even complete darkness. But this test is completely different. This is a solid metal gate, and metal is known to reflect mmWave signals. We already know that a regular camera and a thermal camera can't see through solid metal, so there is no point testing them here. Instead, let's go straight to the RD-03D mmWave radar and see if it can detect me behind this metal gate. This time the radar isn't able to detect me, and that's exactly what we would expect from a solid metal barrier. The detection you are seeing on the screen is actually the metal gate itself, not me. As soon as I open the gate, the radar immediately starts detecting me again. Unlike wood, fabric, or leaves, metal reflects mmWave signals instead of allowing them to pass through. This isn't a limitation of the RD-03D module, it's simply the physics of mmWave radar. For our final test, we are going to do something I have never tried before with any mmWave radar. A regular camera and a thermal camera can continue detecting people even while the camera itself is moving. But can an mmWave radar do the same? Let's find out. I will start by carrying the radar while my brother stays in motion ahead of me. If the radar can accurately track him while the sensor itself is moving, we will take things one step further and mount the entire setup on my bike for an even tougher challenge. The results are different this time. Unlike a regular or thermal camera moving, the radar itself affects its ability to track a target accurately. That's an important limitation to understand if you are planning to use this sensor on a moving platform. But as soon as I made the radar stationary, it immediately started tracking me accurately. So this test clearly shows that the RD-03D mmWave radar is designed to operate from a fixed position. Mounting it on a moving object such as a bike or a vehicle significantly reduces its tracking performance. If you would like to build this exact project yourself, the complete firmware, Android Studio source code, and all the project files are available on my Patreon. The link is in the description below. And if this is your first time watching this series, go back and watch part 1 and part 2. To my YouTube family, thank you for all your support. I read your comments, I reply, and I love bringing your ideas to life. So, what should I test next? Let me know in the comments. Your idea could be featured in the next episode. So, that's all for now. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in the next episode, and thanks for watching.